Yeah, so this is the package specialization subgroup meeting on the 16th of March. So let me share my screen. So yeah, I did. Yeah, so I just put some agenda topic in. By the way, for everyone, if there are topics that they want to discuss, please add them to the agenda. First of all, yeah, maybe some housekeeping. I still continue to ask for a volunteer. I can to actually lead or even co-lead, so we can be co-leading the sub-project going forward. So if there is people interested, I would be happy to share or even mentor or yeah, help the person in question. So that's one. So if you're interested, you can always send me an email and we can discuss. Secondly, yeah, so we were discussing the meeting. So now I think there should be a calendar invite for everyone to have the meeting. So at the moment I opted for Monday, Wednesday, and Thursday at 8 o'clock, 8 a.m. PST, sorry, to be clear. That should be a bit better for our Indian friends and colleagues. So that's a little bit the housekeeping. If there is, yeah, so I also, if there is, everybody has access to the document. So what I try to do in the top here is try to build a little bit the overall things that I believe we somehow agreed upon what we should do. So first of all, build generic libraries that are reusable. And then in the function, build them in an idempotent way. And yeah, the parsing of that data is still, we have to probably experiment a little bit to see whether we come up with a certain approach. But I try to summarize it here. And then if people have things or notes, please add them to the document. It's open for everyone to add comments. Were there any questions still open or pending from yesterday's or the day before session? Or was it clear? By the way, one thing, and maybe John, that's good for you. So I'm of the opinion that I use KubeBuilder for controllers as a baseline personally, because it's open. So there was some people who asked me, if you build a controller, where to start from. I always point to KubeBuilder. So I'll maybe put a link into the minutes as well. Then we can, but that's how or my personal view, or what we should do, because that's the, I think, community-based approach. I think there's also operator framework, which is more a Red Hat based approach, which is built on KubeBuilder. But I always start from the base for it.
Yeah, I think that's reasonable. I mean, I think some people also want to write them from scratch or whatever, but I think for most of us who are, who haven't been writing controllers day in and day out for years, that's the easiest place to start.
Yeah. Sandeep, you have a question?
Yes. Yeah, so we have started going through the code. Yeah, that is good. It is giving a lot of clarity. But what I want to know is, have we already discussed or decided the scope of work till R1 for this subgroup? I mean, at a concrete level, that okay, these are the KPT functions that we will be writing for SMF, AMF, UPF. I mean, at that granularity, because that will help.
Yep.
If people want to volunteer or lead, I mean, they can choose their area and.
Yeah. Okay. Yeah. Good question. So our group, basically, in my view, I try to summarize in these buckets, right? Of course, they are going to be used for both SMF, AMF, and UPF, right? So they are. The idea is to make them generic, although we still have UPF deployment, SMF deployment, and AMF deployment as CRDs. So there is some potentially variations, but these, let's say, functions or operators are kind of working on that. one thing, so for me, the IPAM one, so this will have to be a controller, right? The VLAN is, in my view, will be a controller. NAD at the moment is a function, and I think it can stay like that. The NF injector, we still have to discuss a little bit here on what to do and the approach we take. So that's one that is still a bit, so we still have to do a bit of homework on how that would work. But my view is that this should potentially be a function, and that depends mainly on how much we can get from the package management team. So if all the CRs that we need to do the work in the package specialization, then this can be a function, right? If not, then we have to potentially do a controller. And then there is one, still an open item, and there is potentially one more, which I always forget. So there is an NF, and maybe we have to change the name here, but this is kind of where it starts from. So this is the thing that at the moment we have this NF injector controller. It basically does the IP allocations and expands the UPF deployment. And then there is a function, which I don't know the exact name at the moment, which basically takes IPs and VLANs and injects them into the UPF deployment, SMF deployment, and AMF deployment. So that is also kind of an injector. So we probably have to change the names here. And that's definitely a function. And yeah, so those are the ones. So this probably the name will have to change. And so that's what our group will do together with the watcher. So the watcher, I am waiting a little bit because next week we will have the seed code from Google, and then we can see what is there and we can discuss the approach. So that's basically where we are pending upon that. I believe that next week, Steven in the SIG automation will do a little bit of a deep dive on the seed code. And so what we will have to do, or what I want to do in the group is figure out how it works and whether it's okay for us and how we are going to use it and stuff like that. So that's still pending, but this is what we in our subgroup should focus upon.
Okay. Yeah, this helps, but we still have to refine it, right? So we will wait for the watcher injector code, refine it to a level so that it could be distributed. And yeah, I mean, I get it, these items at a high level, but still end-to-end picture is still not clear. So yeah, we have to refine it.
Yeah, so one thing I think that will help a lot is this is all driven by it's all driven by what the packages need, right? So we need to define what a package looks like to deploy a UPF, an SMF, and AMF, and then we will have a better and much clearer picture of, okay, what problems do we need to solve in rendering that, or in bringing that configuration to a readiness for deployment. So some of those problems will be solved in the package management subproject. Some of them will be solved in this subproject. Some of them will be solved likely in the workload cluster subproject. So in the next meeting right after this, I'm going to talk about the project management stuff. I think part of our goal there, and it doesn't have to be there, is to start writing packages that maybe don't do everything yet, but start to discover or identify what these gaps in the platform are, and what the problems are that need to be solved. So that will, I think, bring a lot of clarity to, like, oh, we need this specific function to do this specific thing because, oh, we're missing this value and it comes from here. Like it's a little bit hard to do that a priori without like actually going through and trying it.
Yeah.
Okay. Yeah.
And so one of the things that I wanted to do is, because we will probably own some of the CRDs. So first, what my goal was a little bit on education on what happened so far, right? and then I think start focusing on the CRDs, put them in Git, right? So put them, and then people can see it, can look at the code, and then I think what we can do already is build these methods that we were discussing on how to leverage the CRDs, right? So that we have, because we probably use the CRDs for us to function, which means that typically it's a YAML-based processing that you have to go through for other methods. So we can already start with that, and then we can see how to fit it together. So step by step, we will get there. But so it's going to be a journey, right? Yeah.
Okay,
Liam?
Yeah, I just have we thought at all yet about the repo structure? Or it's usually one of the first things to think about. Would there be a repo per sub-project? We don't want to fall into, what's the name of the rule, where the code that's produced maps the organization, or is it a single repo for all an FEO? Or have we thought about that?
I think there's a single repo for the Nephew as an organization, but yeah, John, maybe you can chime in. You probably have a better
either way, I was just going to say we've talked about it a little bit, and I think our leaning was towards a repo per component, as opposed to there is a FEO repo. We can, if you look at. This is always a difficult decision, right? There's more overhead by creating a bunch of repos, and it's a little harder to find what you're looking for. But when you have a mono repo, it's sort of pain now or pain later, and I'm not sure which is better. So our leaning was towards an API repo that would contain the Go code, the Go marked up code for the CRD structures that is used to generate the CRDs. And then I think what we talked about yesterday or whenever it was, is that we may, alongside those, lay down libraries for manipulating those as YAML or as JSON, like as unstructured things for within kept functions, for example. And then the controllers code themselves, for the controllers that operate on those, would live in their own repos. The only potential concern with that is, it's not how KubeBuilder lays out things by default, but I don't think that matters. I think we can still use the boots, I haven't tried it, but I think we can still use the scaffolding and stuff from KubeBuilder, even if we separate it out a little bit. So that's the current thinking, but open to suggestions as well.
Yeah, because I think, in the project I work on and on, I think we overdid it a bit on repos, and we've been paying for it ever since. It just makes builds the whole thing very hard and complicated. But it's a judgment call. You guys would know better than we would at this stage.
Yeah, but that's also a line I saw a little bit on how I was thinking. So per API or CRD repo, right? Or that could be maybe a big repo with a subfolder in it, right? Where we contain the methods and libraries for that CRD. And then we have per component, whether it's a controller or a function, there would be a separate repo, I think. Yeah. That's a little bit the guidelines, right?
Yeah, that's fine. That's great.
Yeah. All right. Any other question? Yeah, so what I wanted to do today is walk you through a little bit the IPAM, just to see what is happening there or how that operates. Just to give you, to level set a little bit. Is that okay? So where do I start? So first of all, when I started the IPAM, so the architecture of the IPAM is like this. I actually have to update a few of the pictures, but so the idea was always when I started this, okay, we have a backend IPAM that does all the allocation, and that's what we are using, right? But in real life, people have IPAMs for themselves. So what I basically try to do is, okay, if this is Infoblox or this is Netbox or this is a system from anyone on the service that are being used, we should eventually be able to integrate with that, right? So as a result, what we wanted to do is make this interface pluggable. So there's a gRPC-based interface. And so what basically happens is there is a client-side library. So you could say this is the server that actually holds the IP information, right? And there is clients, and so the IPAM injector is one of those clients that is triggered based on this package revision. And by the way, all of these at the moment are also implemented as clients. So that's what I have to do rather than, so what I was doing before is I had a direct interface to the data structures here, but I also moved them towards the gRPC-based approach because then it's all generic and it's always the same. So that's what I have to update. But in other words, you have kind of a client that allocates IPs based on certain criteria. And then, okay, what I wanted to build an IPAM that is generic, because when you look at our job, you see that IPs are being used in various places and for various purposes. Even, I believe, so even if you look to, and Liam, it would be good to get a view from you. If you look to the Nokia, for example, Nokia, let's say, core elements, we use actually already 3 types of IPs within our system. So one is used as the one that is used for multis, right? So where you basically use it for secondary interfaces. Then we have what we call, or what I call loopbacks. So these are interfaces that are not tied to an interface, if you are to a physical or a virtual interface, but they are a bit floating around. So it's like I call them loopbacks. And then we have pools, right? So pools for UEs to basically get an IP allocated from a pool, or that could be DHCP pools and stuff like that. So, but these are like 3 different kinds of IPs that we would be using, right? And so the IPAM system that is here is actually serving all of these capabilities. It's also built in such a way that we can allocate or you can provision through an API and through a CRD a set of attributes. So, and there are CRDs associated with the IPAM module itself, right? So in other words, because what we do in our Ansible playbooks at the moment, when we build the environment, we are allocating, and this is, I think there's a PR open. So in the POC, we basically allocated one subnet for all for a given network independent on the amount of sites, which was actually not a good approach. So that has been changed, but the PR is not merged yet. But so when we create, so during the Ansible installation, you actually see that there is a bunch of CRDs. I think I have the system, probably I have, wait, where is my terminal? I can actually show you here. So if you go to temp, if you use temp as a directory, there is, where is it? IPAM, I think it's IPAM.yaml, right? So what you see is that we provision a set of IP addresses already ahead of time, okay? And so that happens, so that is provisioned through a set of CRDs. This is still the example from the proof of concept. So it's one subnet for basically the whole, for all the clusters. If you would implement the PR, you will actually get a subnet per cluster per network instance. Okay. Now, the second thing that is in the IPAM is also what you see is that typically in the, let's say 5G space, but it's mainly in general, we allocate IPs within, I call it virtual router or I use the open config terminology. So I called in there, we use network instances. So it's kind of a virtual router context, which means that you can also have overlapping IPs, right? So these are all the type of capabilities that the IPAM supports. So you can either through a CRD say, I want, so you create a network instance. So what you see here, for example, is I create a network instance with a name. That's the name. What you then do is, okay, this, you can still use it like that, but so it has changed a little bit. So we allocate a prefix in that network instance. And then what you basically do is you allocate here, for example, a /24, and you allocate it to be a gateway. So there is also the whole IPAM system works with labels. So you can, and those labels, I classify them in two categories. You can have labels that are, I know that actually, yeah, three categories, if you will. One is what we call a system-defined label. So I basically assign labels within the backend to those routes in order to check, for example, overlapping IPs, if it was already allocated by someone else and stuff like that. So these are what I call system-defined labels that are basically, the IPAM code under the hood basically allocates them. Then what you have is you have what you call user-defined labels. So these are labels that you as a consumer of the IPAM can use to do something, and they have certain purposes. So for example, what you see here is there is a label called, this is a gateway route, right? Yeah, John, let me finish this and then I'll get to you. Is that okay? So, and then so that's one thing. So these are labels that you associate with a route. And then the third category is we have what we call label selectors, which are used to basically select a prefix within a certain labeled set. And they basically then figure out to which route they belong. And as a result, you can get a prefix within a certain subnet if that was allocated. So yeah. So John, you had a question?
Yes. So so one thing I'm doing in for the package management thing is I'm just, because frankly I don't know much about telco network functions, but I do know about DNS. So I'm creating a little example package that has a topology of like a regional DNS caching DNS structure. So there's a regional DNS that's configured with, you know, a larger cache and blah blah blah, and then there would be edge DNSs that use that regional one as their upstream. And so of course these are cross cluster. So my thinking is to solve the problem of like, how does the edge one know what upstream to talk to, what IP address to talk to? I was going to use your IPAM allocator. So what that means is that I need for when the distribution or regional package gets deployed, it's going to allocate an IP address. When the edge one gets deployed, it's going to reuse the same one, or the allocation could happen from either one. But the point is they both have to get the same one. So I just want to, is there anything special I have to do to differentiate between allocation and reuse of an IP based upon the metadata?
No, so, okay, so the way it works, so everything is worked with labels, right? So if you use the same label selector, and if it was already allocated, you will get the same one if it matches. And we use, so the way it works is that I use these user-defined labels plus so the way it actually works is the following: is there is a in the IPAM, what I'm doing under the hood is it works with, so the IP address is allocated from an owner GVK, if you will, right? So there is, sometimes it can be the same object as the IP allocation itself, but it can also be that it was allocated on behalf of another thing, right? So for example, think of a package that if and that depends on how you consume it. You can basically say this is the owner. It's kind of a source identifier on who allocates it. So if you want to get the same IP addresses from two sites, you have to ensure that they match. Otherwise, it will say that this IP was already in use, and you don't get the same one back. You see what I'm saying?
Okay, no, that sounds perfect. So yeah, I'll try that out probably later today.
Yeah. So the labels, so the whole label mechanism under the hood is used to basically figure out. One is so there is two ways. So there's multiple ways you can get an IP. By the way, one is you don't specify it ahead of time, and you basically say everything is perfect, right? Or everything is possible. Now, of course, what can happen is that you lost the IP, and you do a new allocation with all the same parameters, and it's still in the backend system. I will return you the same one if it matches. So in other words, if the labels that you use in order to do the allocation match, you will get the same one back. If they are not, you get the next one in the system that is free for you. So then you get a new one. So it depends a little bit on how you use it, but the labels are, it's rather flexible to actually, from two allocations, get the same one or get a different one. It depends on how you set your labels on the allocation.
Yeah, that sounds like exactly what I need. So that's awesome.
Yeah. Sandeep, yeah, you have a question?
Yeah, so follow up on what John said. So, so the solution that John just, proposed or is working on. So as I understand, so that will enable cross-cluster communication over the service names, and this solution will basically automate the, service names for both primary and secondary interfaces.
Yeah. Okay. Wait. So I'm not yet doing DNS. So at the moment in the IPAM there's no DNS, right? So in other words, you can build a DNS on top of it that interface it. So I wanted to stay away from that at the moment, but you could easily build a DNS system on top. So the way you have to look at is the following. The first attribute that you have to be aware of is a network instance. So a network instance is a virtual router context. It's not contained to a cluster. It can span all the clusters, right? So that network instance is kind of a virtual router that potentially spans across the whole, all the clusters in between, if you want to operate like that. And then what happens is you allocate IPs within that network instance to be able to, and you can allocate an IP globally, right? So that you don't care where it is. So it's like it's a floating thing. It can appear everywhere, or you can allocate an IP or an IP subnet per location. So you can say, I want a /24 on this edge cluster on this network instance, right? So you can also do that.
Yeah.
You see, so I didn't want to, let's say, limit the use cases on how to consume it, because I from what I've seen in my career I've seen many use cases, and if we constrain it too much, we will get a problem. So I want to build a very flexible system, but of course, for people to understand how it works under the hood is a little bit, it takes a little bit of time, but you have to experiment with it.
Yeah, I got that, but still, a DNS solution on top of it will complement it, right?
Yes, 100%. Yeah, and this is for the time being, I stayed away from it, but actually, I agree with you. This would be a great addition, and then you can have, because see, we will need somehow of a service discovery point, and if we use DNS behind, so for example, let's say we have an N4 on UPF and we have an N4 on SMF, and they both need to communicate. If we say this is the DNS name that they should use, it becomes it becomes out of the box, if you see what I mean. Otherwise, we have to say a peer, so we have to basically configure a peer address on one side, a peer address on the other side. So the orchestration and the automation becomes way more difficult. So if we can rely on DNS, it becomes way simpler.
Yes,
Yeah.
agreed.
So yeah, so my example has nothing to do with DNS of the system. It's like, this is just, think of it as an application that I'm deploying using Nephio, and I'm just using DNS as my application example because my background is, and I understand DNS, so it's easy for me to do, and it's a simple application for caching anyway. But yeah, if we want to implement DNS on top of WIM's IPAM, I can help with that too. The other thing I wanted to ask is, so here's the other kind of trying to exercise. I'm trying to exercise some, with this example, some use cases of the way things could go. So imagine the same structure I just talked about, but you have multiple regional clusters in the same region. So all the edge clusters are going to use as their upstream DNS the regional clusters in that region. But if you have multiple ones, you're going to run, for say redundancy reasons, multiple DNS instances. So can I make a request to your IPAM system that returns multiple IP addresses rather than one? So I would say, give me all the DNS, all the IP addresses that match the label distribution network and the region foo and the service DNS. And it would return me 3 IP addresses, or one for each that's been allocated by different clusters. Because when the allocation happens, I would say, give me an IP address for those things plus cluster 1, plus label cluster 1. So it would give me 1 IP address. Does that make sense? Can I do that kind of underqualified query?
At the moment, you have to create 3 allocations. So what you can do is you can ask for a subnet. So you can ask for a prefix which is not contained to /32 or /128. But you can, so at the moment, but we can change it. But at the moment, there is an IP allocation, but it basically returns, so it returns a single IP plus the gateway if you ask for it.
Okay, but if I ask for an allocation that's underqualified, meaning it matches multiple. Okay, you'll just return 1. Okay.
Yeah.
Okay. All right. That's fine for now. I don't care for now. I'm trying to, exercise. We can add it as something to add in the future.
Yeah. These are things we can add. So at the moment, it returns only 1. Even if you have, if you look if you look to the technology that is behind the IPAM is a complete router. So it scales massively. And it uses the Go BGP backend that sits behind. So it scales to millions IPs basically. But so at the moment it's 1 because I wanted to make it simple. But I added the gateway because what you see in some of our use cases, for example, that you get an IP, but I also want to get the gateway. So you get that, right? But you can, for example, what you can do is you can ask for a prefix which is not contained to /32 or /128. That you can do. So I will return the whole prefix. But there's only 1 prefix that you get back.
Okay.
Yeah. So there's various things that I did. So I created here a table. So for myself, for my testing, and probably it's way too detailed for now, but you see the differences, what actually happens between those different types of interface. So at the moment, when you look at the IPAM, we have 4 kinds of prefixes that are there. One is network. It's really used typically for our virtual IPs and stuff like that. So virtual interfaces. Because what you typically see for this type, what you get is when you get a subnet, a /24 or something like that, it's the broadcast domain and the first, so the first, the last. So there is a set of things that gets allocated under the hood for you. You have a loopback, which is basically something that is not tied to any physical interface. a pool is kind of something that you typically use for DHCP pools or UE pools, right? And then you have an aggregate, which is basically a way to structure the IPAM and make a bit of a hierarchy. This is similar to what Netbox does, basically. But you see here, so these are kind of, so you can ask for a prefix, an allocation with a prefix length of 24, so you get a subnet back, right? And so you can ask for an IP, so you can ask for a specific IP out of this prefix and stuff like that. So it's there's lots of flexibility in it, and of course that makes it a bit complicated, but maybe to understand. But on the other hand, it's rather flexible, I think. Now maybe we should probably look at the code a little bit of the IPAM injector to see what actually happens, or what the piece that we have to do, or that I did so far to actually do the POC, right? So the code is here. So what you see actually, it's if you remember the NF injector code, you see that it's actually where is it? So it also watches similar to the NF injector. It watches for package revision. So it's ports that basically schedules us. Yeah, Ravi, you have a question?
Yeah. So when you talk about vRouter, right? I mean, for me, it gives always, when you say vRouter, that means there is my mind goes into a data plane. Are you talking from a data plane where you actually have a vRouter and then which abstracts out the physical links, physical interfaces, or is it like when you talk, you're talking from a purely control plane in the nephew management perspective?
Yeah, pure control plane. Yeah.
Okay. Yeah, because in the picture I didn't see anything like a
layer
vRouter.
3 address. I think it just means a layer 3 address space, and then he's using the code underlying for managing routing tables to handle all the complexity of IP prefixing.
Yeah, the IP prefixing is a very, very difficult structure, right? So if you ask for something, you have to fit it to the subnet mask and whatever. So there is some computation that you have to do under the hood. But there's no data plane involved at all.
Okay. And just another question is like, where does the specialization on if it is like, whether you're using MacVLAN or, SRIOV comes, does it reflect at this these CRD levels when you actually create this? Okay.
Not for IPAM. So for IPAM, it doesn't care. So if you use it for MacVLAN, IPVLAN, it doesn't care. You basically ask, I need an IP in this context, and that's basically what it does. So it doesn't care whether how you use it.
Okay, yeah. It's agnostic to the underlying binding. Yeah. Okay, got it. Thank you.
Yeah. So okay. So for those who were on the call, you see that this code is actually almost the same as the one that we saw for the NF injector, because what we get is we get ports which at regular intervals are going to say, hey, I have a package revision, there are some conditions and they might be unsatisfied, and please take care of the allocations, or take care of them if you are the controller of questions, right? So the first thing that we do is the same. So we get the package revision, we look at the unsatisfied conditions, and if there are unsatisfied conditions, we inject IPs. Because remember that in the POC, the IP allocation CRs were already added to the package by the NF injector, right? So this controller does not inject the CRs. What it does, it actually allocates the IP addresses for a CR that was in an unsatisfied status. Okay. And they basically, so in this case, so in the POC, we had an IP for UPF for N3 and 4 and 6 and pools, right? So all of them got allocated during that same reconciliation loop. So it's not one for each, it's basically all together, because we look at the full package content, and then we are basically figuring out on how to consume them, right? So if there are unsatisfied conditions, we will go into this block, right? And so what will happen is that we wait a minute, so I have to look. That's a long time I looked into this code. Yeah, so first of all, we are going to see whether or not there are already IP. So probably the code is good. So there is not so much documentation here. So we have to add that. But so we are walking again through the buffer, so which is a flat list, to figure out some information to look at that, right? So this is basically the update. So actually the actual injection actually happens here. That was being called by from here, right? So here we are injecting the IPs. So this is the code that that does that. So we are getting the list of all the package resources. We walk through them. We see which IPs. So we look again. So this is basically YAML again, right? So here we look at the YAML and we look at the API version and the kind to figure out which IP allocations are there. And then basically this does the call to the IPAM via gRPC interface. So there is a proxy, because I also do a bit of caching. So at the moment, so there is a caching in this client that if you have, because what you see in Porsche, it schedules on a regular basis. And so I want to take care about refreshing and stuff like that. And I want to do it in a scalable way. So there is a bit of a caching there that we don't overload it. Let's say if you need 100,000 IPs at some point, okay, that it scales, right? So there's a proxy here which basically does a bit of caching to actually ensure that we don't overload the IPAM. At the moment, there is no scale, but it's built. I try to build for scale to some extent. And then, so this is the response that we get back from the gRPC call. And also to tell you, the gRPC interface that I try to build, it's a generic allocation schema. So in other words, I want to reuse it for VLANs. If we have later on other schemas or other resources, we could use the same schema for all of them. And we only have to add the client side and the server side, but all the rest in the middle, like the caching and the proxying and stuff like that, remains the same. So we don't have to change it. So what you see is you make the call, either you get an IP or you don't get an IP. If you did not get an IP, we will add that that information into the so in the feedback. So basically when there is a failure, we will basically tell you why it didn't work. So you can actually see the reasons behind. And if it succeeded, we will update the allocation. So we actually, the status of the IP prefix contains the IP address as well as the gateway, if that is relevant. And it actually updates that. And then basically when it's done, it updates the packet. So if you look to the injector, it's fairly simple, right? One thing I did not explain, I think, is this is the code that does the IP allocation, right? So what you see is that when we add the allocation, so this is actually a CR that was put by the NF injector. And so what you see here is depending on the type of prefix. And so this is basically the prefix kind. Depending on them, I will have some changes. So there is different processing. For example, a gateway you will not be able to have under a pool or under an aggregate and stuff like that. So there is some logic there that you need to adhere to. But yeah, it's fairly simple approach to handle in the injector side. Does that make sense or clarify?
Good.
So any questions or is this clear? Yeah. Mikio, yeah. I'm not sure whether I
Yes.
spelled your name correctly. Yeah.
Yeah, please call me Mikio. So I have one question. So I'm still not sure how when operators misconfigures and IPAM leasing some bad address prefix or something like that, how can we withdraw such misconfigured IP allocation?
To withdraw it, you mean?
Yes.
So there is also a deallocation interface, so you can allocate and deallocate. Yeah. Plus,
Yes.
what also there is a refresh mechanism in place. So, for example, if IP was allocated and you don't refresh it, the IP will be deallocated after a period of time. So it's kind of like a DHCP. It behaves like a DHCP server.
Okay. Thank you.
So you can deallocate, and you can there is a refresh mechanism to basically indicate whether you're still interested in this IP. So when you get them, yeah. So that's the new thing that I added as well. This was not there in the POC because I didn't have the time. But in the meantime, there's a refresh mechanism in place to tell you how long that IP is valid, and then the caching and stuff like that takes care of that part. So the client doesn't see that. It's all hidden for you. Now, maybe one thing that I also did, and maybe that's probably good for a discussion, if there is no further questions at this moment, is I created, and I think this is a conversation. I think we went through this slide at some point, but we never, I don't know how many people fully understood or understand the whole thing. But so, by the way, should I make it complete in presentation mode, or is this okay?
Please put in presentation.
Okay.
Okay. So I am mainly familiar with Nokia, but I also talked to Sagar, and it would be good, Liam, and for people from Ericsson or other vendors to actually get a view on it. And I think it's important for us to be on the same page here, because this will probably determine how our CRD structures and so on works, right? So what I try to draw here is, if I look to a network function so that we have, but actually it's not only specific to 3GPP. We have other network functions that are completely out of context. They operate in a very similar way, by the way. So what I see typically happening is that there are three types of interfaces and then related IPs that are being consumed. So the first category is what I call the virtual NICs, or sometimes physical NICs, or so anything that is directly attached to something, and that can be a virtual router or something like that. But so there is this category of what I call virtual NICs or physical NICs. These are the ones typically in our network functions that I either consume Multus or they consume a CNI, right? Either the default CNI or the Multus CNI for now, until we have multi-network interfaces or something like that. But so these are the ones that consume a CNI interface or so on, right? And you can basically add as many as you want. There's probably a limit in your function on how many you can add. So that's one category, right? The second category that I see is, sometimes you can move them or move the second category. So you can use them and assign them on the physical or the virtual NIC, if you will. But what we also see sometimes is that or at least within Nokia, we allocate what we call loopbacks or loopback interfaces that are not associated directly to that physical NIC. And the reason we do that is, if, for example, this interface goes down and it comes here, your N4 IP stays the same. We don't have to change it and so on and so forth, right? So this is kind of an IP that you could actually think of it as a service IP in Kubernetes, but they live inside of the network function. So they're acting in a very similar way, because if you have two routes to this IP, you can do load balancing and what have you, right? So you can basically get to it via various paths potentially. Even this IP could span multiple pods, and it will still have the same IP address. And so there is so that's what I call them here 3GPP interface, but in my terminology they are loopback. So also in the IPAM, and the reason why I'm discussing this is twofold. One is for the IPAM, but secondly also the way that we have these CRDs that are in the package, because in my mental model we need to have a CR for, or ideally, because now we have the package, so we can make it very generic. I personally would like to have one of these interfaces for each of these that represent each of these elements into a network function, and as a result, then it becomes very easy to consume that. And the third category is pools. So pools are typically used. So in the POC we use them for N6. So this is a larger subnet where when a UE attaches to, for example, the UPF, it gets an IP assigned from that pool somehow. So these are what I call the three categories. I don't know whether people agree to these categories or have different views. Yeah.
Just a quick question. The VNIC is described here, but there's no PNIC, right? You keep referring to or PNIC.
Yeah.
There's no
real. Yes, so there is no physical interface here. That's correct. So it's all pods, right? So, but I make the analogy to a physical NIC if you look at this as from a physical.
Okay.
People who are still, yeah.
Because
I make the
in my head,
similar
in my head, it's like, where's the PNIC? Sorry.
No. So it's just, maybe I should remove it, but I thought it was clarifying, but maybe it's confusing.
No, that's
more,
good.
so,
That's good.
Yeah.
Thank you.
So do you guys see? Yeah, Liam. Yeah, thanks. Go ahead. Liam, are you on mute? We can't hear you.
Can you hear me now?
Yeah. Yes. Yeah.
Yeah. I just I'm in the network management part of Ericsson, so I'll have to go and check this Vim, and I'll get back to you.
Okay. Perfect. Yeah. Thanks for it.
Can you hear me?
Yeah, because see, yeah. So this is kind of what you see is in my view. So at the moment in the CRDs we have network attachments, right? Maybe the name we have to change a little bit, but the idea is that for each of these elements we will create a CR within the package, and this is the thing on which the IPAM, for example, would work. So for example, this one is represented as the IPAM kind network. This is represented as IPAM kind loopback, and this is represented as IPAM kind pool. If you see what I'm saying. So so there is because they behave differently, right? So here you typically have a gateway, here you don't have a gateway, right? So there is a different, let's say, underlying methodology or how they behave is a bit different. So that's why, although the CRs are generic, the behavior based on that kind is a bit different on how some of these things work, right? So that's why I wanted to discuss that. This is, for example, a way to, so why did I build this picture? For example, there is, for example, if you deploy a network function in multiple pods, for example, you have pod 1 and pod 2 on the same UPF, you could deploy it in such a way that you have a dedicated N4 per pod and a dedicated N3 per pod. That's a deployment option. You could also deploy it like this. Right, and this N3 is bad, so this should be removed. But so you ask for a single N4 that spans all the pods of a given network function. So you can already see that the logic, so we need to build some logic in it to be able to satisfy or accommodate different, let's say, deployment or implementations on or how they get consumed. So that's why I built this picture. So in the context of IPAM, so this is a network instance because this is kind of a virtual router, right? So this is like I think of them of a VPC, but they are actually a routing table within a VPC. That's how you should look at them, right? And yeah, we are almost running out of time. But so this is a network instance. So that means that you can have the same IP prefixes on the yellow as on the orange, right? And so that's basically, I believe, from an architecture point of view, what we should build in order to have the flexibility to have different deployment scenarios. And I think at the moment with the framework we have the ability to do so. Right? And we can, for example, at the moment in Free5GC, and maybe I had to clarify, at the moment what we do is we have a single virtual NIC, and the N4 is attached to the physical interfaces. That is also a deployment option that is valid, by the way. So that's what we have been doing into the POC, and that's probably what we will do for R1. But I want to make it flexible that we can do other scenarios if we need to. Yeah. Liam, you still have your hand up. Is that?
No, it's I look you put it down.
Yeah. Then you're next.
The share N3 and N4, is that more common in real world deployment? Which one is more common? Yeah. Or how are they used? The logic
it
of
depends.
which one? Yeah.
It depends. So I'll tell you the high level view is that this is typically used in signaling on not high demanding traffic environments. So this is what is used.
That makes sense.
And the reason why, and this is mainly used, for example, typically on UPF in very high loads. And the reason is this avoids sending traffic. So for example, what you have here you have a shared N4. So it might be that actually your control plane context happens here, but you enter this pod. So that means you have to send it across the fabric towards this side, and that reduces performance. So what you typically see is that this is used for it's not 100% correct, but mentally that's how you should think. This is very used in very high traffic environments, and this is really used for signaling and low traffic environment. Because this is from a management simply. We are running out of time.
Actually, we're over time, and I don't know what'll happen if I start the other meeting while this meeting's still going. If it'll kick you all out or what.
Yeah, start it. I'll try it. Rafi, I'll quick answer your question.
See what happens.
Oh yeah, sure. Yeah. So it's the same on the N4 shared N4. Is it for something like a? Is the UPF instances too different? Because typically you have what is that PRCF? I mean the SMF. It's a point-to-point interface, right? So you require, if you have two, the SMF is supposed to see two UPFs. So I would say that would be at the IP level. What would sharing mean in that sense? It's not an active kind of a failover scenario, right?
No, so you see them. So they will be present. So what happens typically when you get a GDP, when you get a session request, when you have in this scenario, these are seen to the be as two different UPFs at the end of the day, but as a control plane, it's a single one, right? So from a control plane point of view, they are seen as one, because you have in 3GPP, you have a GTPC, which is control plane, and GTPU, which is data plane, right? So we are doing all kinds of tricks with that in order to optimize the performance, right? So in other words, as a control plane, you actually behave like this, but as a user plane, you actually behave like that. You see?
Okay. So there is something else that would DMAX the specific UPF instance then, I mean, so that the packet goes to
Yes,
the
yeah,
right
and that
SMF
happens.
with,
That
okay, okay.
yeah,
Got
that
it.
happens through that whole control plane of 3GPP as well as internal implementation to do it in the most optimal way. But yeah, so
Okay.
there's all kinds of magic that happens under the hood because of it. Yeah. Yeah.
Okay, sure. Thank you.
But yeah, but the reason why this is preferred is because here you see this element as one big thing, right? Whereas here you see it as individual element. But what we typically do is the control plane, we optimize in such a way that for data plane performance, we do this mode mainly because this improves the capacity. Okay.
Sure. Yeah. Thanks.
Yeah, we are over time, so I'll stop sharing and then I'll stop the recording. If people interested in the other meeting, then please join there, and we'll be back on Monday, I think. Yeah. If people have topics, by the way, please suggest them on the agenda. If not, I'll try to come up with something. All right.
Okay.
Thank you.
Thank you.
Thank you. Bye.
Thanks.
Thank you. Bye.